Hello guys, welcome to another video of mine. Today we are quickly going to look at some questions on the just concluded Waec 2023 chemistry OBJ. Apologies, chemistry is not showing. So it's a set of chemistry questions. I think there are 50 in all. We are actually going to be tackling them all and providing solutions to the objectives. So let's start with the questions. Excuse me. The first one says, which of the following laws or theory cannot be explained by the application of kinetic theory of gases? Now, these are your laws you have studied before in your junior classes. Now, Darting law of atomic theory or Darting's atomic theory is not under the topic of kinetic theory of gas, because you and I know that Darting atomic theory is talking about John Dalton postulate of atom. Every other options like Charles, like the Luzak law for combining volumes, and the Boyle's law all talked about the so-called kinetic theory of gases. So it's very simple to know. Admit please, less more. Second question. Yeah, the second question. Now, about this second question, the primary component of natural gas. This is also on organic chemistry, which you guys have taught. The component of what natural gas is the what methane is generally used in production of fuel. You guys still remember that? I think this is a common question under the aspect of introduction to organic chemistry. So we can say the option to what these primary components, natural gas, are made from CH4, which everybody knows as methane. The next question, please. Yes. Now, this says thermal cracking of alkanes. Usually, now the cracking in chemistry is defined as the breaking down of what higher organic compounds into their simpler forms by heating or by the use of catalyst. Now, eating means thermal. When you eat and you crack alkanes, when you crack alkanes, I hope it is alkanes. Now they said it's usually that involve the composition. The composition is eating something and breaking it down. So when you eat something, it can be given out. Now, but the word cracking itself is breaking down of higher molecular compounds, especially organic molecular compounds, into their smaller ones. So when you have cracking of higher alkanes, they are going to eat smaller what? Alkanes. I don't know if you guys are saying, they are not asking you something that is so tough. You just use the idea of definition to provide answers to all these type of questions. So my admin, you can move on to the next one. So I believe you guys did well. That is why we are here to do some corrections and look at it very well and see if there is what one or two mistakes you guys make and easily correct it. So the next is carbon is deposited in the exhaust pipes of a car because of dash. Now this is a simple question. You and I know this follows on the organic compound, or what you call octane rating of petrol. I believe you've studied this, but because it's just for me to provide answers to all these questions, I will just be going directly to answers. Now, carbon, you guys know that this petrol that we buy from all these various markets or whatever they are being sold contain different compound or different elements. So as they burn, they release carbon, which is always combined what's very close to the exhaust. So, and the gas they bring out also have another compound we call lead, PB. So what I want you guys to know is what the reason behind carbon being deposited at exhaust pipe is because petrols has been mixed with a lot of chemical, and you know to actually do this, that is why we teach students what they call octane rating, so as to be careful to avoid knocking of what cars. So this is very simple. Contamination of petrol with diesel is not it. Let's turn to black. Presence of carbon in petrol does not make sense. Presence of additive, we talk about that, perfect. Then the last one says incomplete combustion. So that is just a perfect one. But the thing you need to know before this is just to know that what you need to be careful when you are taking answers to some questions, because they can look simple, but technicalities can be there sometimes too. Let's move on, admin. You can move on to the next question. Let's see what we have next. Thank you. Now, this is the first calculations we are doing today, I guess. This is how many moles of copper would be deposited by passing 1 Faraday of electricity through copper chloride solution. Now, this is still not too much of that. 1 Faraday is equals to 96,500. You don't even need these columns. I hope everybody still remember this. Now, CuCl, that is copper chloride, it's written as Cu2 plus Cl minus. As you can see, the amount of moles here is 2 electrons. So what we say is what? According to Faraday's second law of electrolysis, we say the number of Faraday is the same thing as the number of moles. In fact, there is simple formula we teach students, like simple one, Q is equals to Ne. So where N is just the number of integers. So just keep that the number of moles is the same thing as what the number of Faraday. So how many moles do we have in copper chloride? So 2 moles. 2 moles means 2 Faraday. So we are passing 1 Faraday of electricity into copper chloride. So they now say how many Faraday of copper will be discharged. So if we say 1 Faraday is 96,500, 2 Faraday will be equals to, you know what that means if you are looking for the quantity of charge. But in this case, we are looking for the number of moles. So those are things you need to keep in mind. So here, if you say number of mole is equals to the quantity of charge divided by the electron. So the quantity of charge, you can see from there, divided by, so we can say number of mole is inversely proportional. Because why I'm explaining this is most students don't actually understand this aspect of what their chemistry, and they do tend to make mistakes. So it's a simple question. 1 Faraday was passed, and the quantity of what Faraday, you can say from 1 Faraday, you can say see, Q equals to 2E. You get, for quantity of electricity is number of charge, number of Faraday times what? The number of electrons. So if we say 1 Faraday, look at this now, I want to do copper now. Q is number of Faraday is 1 times number of electrons of copper is 2. You can see, so direct way, this is 2. So another person will just tell you, you don't need to do anything, 2 moles, that is 2 electrons. You understand that? So this is correct. Madmi, let's compensate for the time we have wasted. Number 6. Wow, I think we should have number 6 before 7. Or maybe you guys have jumped question. Well, let's move on. Number 7, maybe number 6 has gone away, guys. I don't know. This is petrochemistry is an example of that. Options are pure chemistry. No, pure chemistry is not petrochemistry. Now, applied chemistry. Yes, that should be the answer. Now, what is applied chemistry? Applied chemistry is just an aspect of chemistry that deals with the use of what? Use of chemicals to produce different for the what? Application of chemistry. That is use of what? Petrol to produce what? Additives, petroleum, different type of things. We call them applied chemistry. Look at it, it's not biochemistry, biology and chemistry, not environmental chemistry, that is not. So chemical aspects used in different aspects of life, this is called what? Applied chemistry. The next one, please. Thank you. It says species that occur in a reaction pathway, but not in the overall reaction is called, they are called intermediate. Now, if you have in organic chemistry, when we talk about mechanism, reaction mechanism, we talk a lot about reaction, what we call intermediate. If we have A plus B, then it's giving you, there's a bus stop, let's say, it's giving you C, then D is the final product. A plus B we call the reactant. This guy is called the intermediate. And this guy is called the product. So don't let us waste time. This is perfect, and we can move. Thank you very much. The next one says, which of the following statement is correct? Correct statement require you to have an idea of concept. Now the first one is alkanes with 49 carbons contain 100 hydrogen. I think that's a lie. You know it should be. Let's see how it might be true. So 49 alkane, the general formula is CnH2n plus 2. So let's do that. N is 49 carbon, 49. So 49 carbon, 49 times 298 is correct. This is C49, 98 plus 2, 800. You can see. Sometimes I will not be doing all options or reviewing all the options because of time. Every other options here will be so what? Wrong. Do you understand? The next question at me, this is the way we are going to be doing it because of time. 1 hour for 50 questions, or let's say 49 minutes or 50 minutes. This is the best indicator to use for the titration of ethanoic acid with sodium hydroxide is dash. Now, when you see this type of question, you focus on, this is on your volumetric analysis. Just focus on the nature of the type of acid. This is indicator which we use to determine the end point of a solution. So doing this, we just need to understand that in this case, ethanoic acid here is a weak acid. Then you are combining it with sodium hydroxide, which is a strong base. So in this case, when you have weak acid and strong base, you are looking for something that has a pH that is greater than 7. So the only out of this is phenolphthalein, because the pH of phenolphthalein is about 8.4. Everybody should know that the pH of meteorite is what? Is about 3.2. That is acidic. So for strong acid, meteorite, strong base, phenolphthalein. Very simple. Admin, show me question 11. God bless you. Now this is the reduction half equation of the following reactions. The reaction we want to consider is a redox reaction. Zinc. We have zinc combined with copper sulfate, as you can see. It's giving us ZnSO4. Then copper is being discharged. Solid. Aqueous solid. Now aqueous solid. Now look at this. The reduction outside. Which of these is reducing? Reduction is removal of oxygen. Now oxidation is addition of oxygen. This guy is reducing. Oxidation state of this thing is 2+. At the end of the reaction is what? In a free state, which is 0. So we don't need to waste our time. So if you want to write the reaction after, Cu2 plus has lost 2 electrons to give us Cu. I think you guys should know this. This is the basis or the beginning of writing what after reaction when you talk about electrochemical series chapter. And if I check well, choice B is correct. The next one at me, you can see they are not that difficult. It's just boiled to the fact that we must know one or two things. The first recalculation I'm having now. Now the first one, let's do it the first way. So now we have a 100 centimeter cube. Come here. So 100 centimeter cube. Oh wow. Together. So we have 100 centimeter cube. I don't even know what happened to the head of this guy. 100 centimeter cube of a saturated solution of sodium tetraoxosulfate 6 at 30 degrees Celsius contain 10.5 grams of salt. What will be the solubility? All options are in moles per dm cube. So I think it's a direct formula question. Everybody should know. And if you don't know, solubility is the mass of a substance over the molar mass times the 1000 centimeter cube over volume. So just substitute. The mass is 10.5. The molar mass is 142. So direct. Volume is what you are looking for here. Volume is 100. So you can cancel here 1, here 10. Then you can see it is now saying 105 over 42. Don't worry if you are not good in knowing that 7 can go in this, but that is why I put calculator. But basically 7 ones, 7 sevens, and I think I'm right. 7 times 7 times 5 is 35. So that should be 15 over 6. Another thing that can go is 3 here 3 here 5, ladies 3 here 2, 5 over 2, I'm getting 2.5 or 2 point whatever. But let's see again, directly 142, not 42, that is why I'm having something. So let me just do the right way. It should be done. You can just say from here 105 over 42, 142, not 42. So this is 105 divided by 42. That is 2.5. I think it is what I'm having. Oh, not 42. What's going on? 105 divided by 142. 105 divided by 142. So that is 0.739. So that's the answer. We can just go for that. 739, that's 74. This guy is correct. And me can take over and give me the next question. So guys, be careful. That's the 1 over 42. you are good with that. Question 13. An example of crystalline substance that does not possess water of crystallization. Water of crystallization is also an important topic you might have dealt with in your preparation to the exam. So, water of crystallization, we want to see the one that does not contain. Let's start with the first one, potassium trioxynitrate, KNO3. Yeah, this particular salt does not come with any form of water of crystallization, let it be known. So now let's take all that. Sodium triisocarbonate 4. Everybody knows this is an efflorescent subcompound or substance. It has 10 molecules of water of crystallization. Iron 2 sulfate, Fe2SO4. It has 7 moles in its standard state of water of crystallization. And sodium tetrasulfate 4, that is Na2SO4, also have what its own, that's penta 5, also has its own water of crystallization. The only guy that doesn't have that is that admin can give us the next question to tackle. Yeah, 14 says the salt solution form from a reaction between ethanoic acid and sodium hydroxide. Now, basically, ethanoic acid and sodium hydroxide. Ethanoic acid, we talked about it the other time, that it is a weak acid. This is ethanoic acid, COOH. I want to write sodium ethanoate combined with sodium hydroxide. Now, we all know what is going to be formed, CH3, COONA, then plus what? Hydrogen gas. So this guy is sodium ethanoate. Sodium ethanoate. This is the salt that is being formed. Now, this is the salt the examiner wants us to tell the type of salt. Now, if you watch, guys, what have I removed? I have removed the hydrogen ion in this. Remember, when there is insufficient hydrogen ion, if the hydrogen ion is not completely dissociated, you say it is acidic salt. When it is the hydroxy ion that is not completely dissociated, you say it is the other type of one, basic whatever. Then when you talk about the other one, when it is normal salt, that is the one that is completely dissociate. So in this case, you can see we can ionize this one and get CH3 COO minus then Na plus. As you can see, you cannot say that this guy is not completely dissociated. This is a complete dissociated salt. And this salt now, we can't say it is acidic because we cannot say it's complete. For example, now, if I ask you now, what is the basicity of this one? Here, it says it's a weak acid. It has one hydrogen in it. Do you understand? So it is completely dissociated. It is partially dissociated at this stage. So now, here when it forms salt, you can see, when it forms salt here, we have CH3COOH, then this. So when you say acidic salt, you must think of hydrogen ion, acidic. When you say basic salt, you must think of, let me just give you simple salt related to this one, NaOH CO3. But when you say normal salt, you say Na2CO3. I hope you still remember this. So it is this same thing I want you guys to follow. Hydrogen ion, acidic salt. When it's completely dissociated, he said is this. So if you watch this has gone, but you are still having an hydrogen ion in it. So when you have something like that, it is called what is it? We have choice B, acidic salt. So the next one, let's move on. Well, this is kind of clumsy, but because it is clumsy, it does not stop us from answering it. This is which of the following reactions represent hydrolysis of alkanoids? Alkanoids are called esters. Let's do it under here. When you hydrolyze esters, that is, you are mixing them with water. They want us to know which of them is a reaction that is going to form when we hydrolyze alkanoids. So let's see an alkanoid that is hydrolyzed and see the reaction. So I can't pick this one because it is not added with water. So it's out of it. I can't pick this one because it's not added with water. So I'm left with B and C. I hope you then get to what I am doing. So if we check B, we can see that this is propyl. This is propyl. This is ethyl ethanoate, CH3 C2H5. This is ethyl ethanoate. it's dissolved, it's hydrolyzed with water. Now it's going to give us CH3COO minus, this is on top, apologies. Then you have CH3COO2, CH3CH2. You can see it's not even balanced. CH3COO, this guy is gone. Apologies about that. This guy is gone. CH3COO. Then you are left with C2H5 and with water. So C2H5 with water. This is correct. Know that. That is a balanced equation. Now check the next one. We see that it is not balanced. This one was hydrolyzed. So when this one was hydrolyzed, we have CH3. Let's check. CH3COO. CH3COO. Then we've taken CH3COO. I just want you guys to focus. Taken away. So we are having another H has been taken away here. Watch. So we are left with, this is CH2CH3. So where is the H coming from? CH2CH3. And remember, we have CH3 because that one H has joined this one plus H2O. If you watch, this is what we are having. If the 2H comes here, it should be CH3 CHOH. See, CH3, one of the H, or you say this CH3 is here, then CH2OH. This is balanced. That means the first one is not balanced. Let's check again. Oh, this one does not have H. One H is missing. So this is wrong, whereas this is correct. So it's not about balancing the whole thing. The logic is when you hydrolyze esters, you are going to have what we call carboxylic acid. It's just the reverse of the esterification reaction you have studied in your work. So the answer to this is option C. Admin, you can move to the next one. I think I need to increase my pace, am I right? So 15, question 16, we have to increase our pace. So let's focus on the answers and not too much of explanations here. Which of the following statements about collision theory is correct? Collision theory is just about the theory that states that before reaction takes place, particle must what collide. And effective collision is a collision that leads to formation of a product. Let's see if that is sufficient to answer this question. All collision bring about reaction, not all collision, only effective collision. Rate of reaction is proportional to what? The effective collision. That should be a correct statement, but don't let us jump to conclusion. Collision of molecule to react with split molecule to react, wrong. Ineffective collision bring about this person did not finish, and that is why I call for being careful. This now does not give me justification for my answers, and it doesn't make sense. So I think it should be ineffective collision bring about product. Ineffective collision does not bring product. So I'm very sorry about this and what error from us, right? So I think this is correct answer. Not all collision. I told you that's the answer, but just wonder the rate of what reaction is proportional to effective collision. The rate of chemical reaction depends on what how particle collides. If particles do not collide effectively, reaction will not be formed. We can move to the next question, please. Okay, let's see that. The next says, why are H2SO4 and calcium chloride not suitable for drying ammonia? Guys, you remember that ammonia has a lone pair, and because of that, it is classified as a base. So you cannot use what an acid to react with a base. It will react with it. One thing we look into in chemistry is when we want to choose a drying agent, we must be careful. It is not such that is going to react with it. So let's see if that is sufficient to answer this question. So this says they are corrosive and poisonous. Does not make sense. Are poisonous, corrosive and poisonous? I don't know. React with the gas is the correct answer. That is why we don't use this and this. They will react with it and does not make sense. The next question, please. Thank you very much. Which of the following equation does not illustrate correctly one of the reaction of chlorine? Chlorine was discovered by scale. We can produce chlorine by what they call Dance process, not only your sodium. I said Dance process, Dickens process, but that is not what this is required reaction. There are a lot of reaction. One of the sweetest reaction of chlorine is displacement reaction. Now focus on the question and see, because I think it's testing you on chlorine. Chlorine can react with alkali, hot and cold. So be careful, oxochlorate and sodium trioxochlorate 5. So be careful about these two as well. as part of the famous reactions of chlorine. Let's see it. Now from here we can conclude. The first one is possible reduction of chlorine. As you can see, chlorine has been reduced, and you can see H2S has been oxidized. It's correct. This is correct. I'm not saying that's the answer. I can never say that. Next one is chlorine reacts with NaOH to give us what? Sodium chloride plus sodium oxychlorate plus water. Now, this reaction is in two phases, so be careful. In this case, we are talking about the cold chlorine. So it's also a reaction that is possible. So now, next one is this reaction is not possible, and that is the answer. Wow, how? Chlorine cannot displace fluorine. Displacement reaction. Fluorine is about it's before chlorine. So talking about displacement reaction, so this is the answer we are looking for. When you dissolve what slake lime with chlorine, you have this guy. You know this guy. You guys should know that this particular thing, it's bleach by what? By reduction. Let's move on. That's not what we are doing now. Question 19. Thank you, admin. Then this one says, how many ampere electrons are in this rubbish guy? Sorry about that. Ampere electrons are in ion that has lost 3 electrons. So that means you know what it means. It is no more 26. It is 23. So if it is 23, we can predict how to write that. If you don't know how to write configuration, you can just write it in your 288. Now, you know, the next one is, the way I write my own is 2818, whatever. So if I write 281, I don't want to write the new screw, but you can as well write it. At the time that you are writing 288, you are going to number 23. This is 10, 18. 18 plus what is 23? 18 plus 6, 18 plus 7, 18 plus 5. I think I'm right. 18 plus 5 should be equal to 23. So the ampere electron you are having is the one that is remained for this guy to form what? Octet. You know it? 8 minus 5. So that's a shortcut. And if you want to write the 1s2, 2s2, 2 pieces, 3s2, 3 pieces, 3. So, and you can also do that, then look at the power on top. You are good. The next one, please. 20 or 50. He says, going down group 2 in the periodic table. Normally, dash. Let's see, this one says shielding effect decreases. Now the thing is, shielding effect will increase because the size of the atom are increasing. As the size of the atom are increasing, you expect what atomic size are increasing, the shielding, what the electrons are increasing. So that means they are protecting. What am I saying? I said shielding effects are decreasing. Yeah, shielding effects are decreasing is what is a very, very wrong statement. We are looking for a right statement because shielding effect increases as you are going down the group because the size increase. Melting point increase is correct for period, for group 2 or whatever is being asked for group 2. Now, but it is not sufficient for all members of the group 2. As you go down the group 2, as you go to the last member, there is one that does not follow that trend, but that is not what we needed here. Melting point is a property that what increases down the group. Note that ionization energy decreases down the group as well as what electronegativity. So I think I need to move to the next question. So the next question is 21. Let's see 21. Which of the following elements has its valence in the s orbital? So how do you know these guys? Just write the configuration. But not to waste our time. Sodium is number 11. 1s2, 2s2, 2p6, 3x1. You can see S. That's the answer. If you want to write carbon, carbon is number 6. 1s2, 2s2, 2p2. You can see the guy is at p. If you write others, you are going to see that. Next one, let's save time. Let's save time, please. 22. Please go a little bit back. Are you guys jumping questions or that is your numbering? Next one. I think you guys are this is the second time I'm seeing question that is not there. The following steps are scientific method except we analyze, open-mindedness is not there, we experimentize and we identify a problem. There is nothing like open-mindedness on that scientific way. Let's move on. No, let us waste time. It's a cheap question. Isoelectronic species have the same numbers of, now, isoelectronic, let me charge or ions, whatever you want to call it. Look at it. If I write Cl minus Na plus, or let's say I'm taking Cl minus, I'm talking about which other one? I just want to get NO3 minus. I can say they are isoelectronic. Why? Iso means same, then charge. They have the same charge. So they have the same charge. They have the same charge. So the thing is, it's not the same electron, it's not the same proton, it's not the same neutron. So charges are what? AM. Sorry, you understand that? I don't think this one should be a problem. Honestly, the next one, 25, halfway, time. I have to be fast. Now, my admin will check how you can see I have 30 minutes and I'm halfway. So, though I plan 1 hour for it, I have to increase my pace. This is a question of finding an isotope. You are looking for the relative atomic mass. So, directly from formula-based question, how many percent is this guy? 60%. In just like 60% 0.6 times molar mass is 65 plus the other guy is 40% is 0.4 times 66. This is the way we calculate from the experiment of mass spectrometer. So we can do that as well together so that we don't have issues. So let's see and tackle it together. So 0.6 times 65 is going to give us, I'm waiting for this thing to come up, 65 are 30, as 3, 36, 390, 39, this is 39, plus 66 times 4, this is 4, 4, 4, 2, 4, 4, 24, 2, 6, 4, 2, 6, 4, that's 26.4. So I think from here, my calculator is not available. This is 65.40. So this is correct. 65.40. So sometimes we may actually not. Let's move on. The next question is this. Now we have the pair of compounds that belong to the same homologous series. Homologous simply means compounds that have what that only differs by CH3. You know what I mean? So just check those compounds and what try to see the difference between them. If you add CH3 or whatever to this, I said CH3, CH2, please note that that's just members of homologous series. So if you add, it doesn't make sense. If you add CH2, it's 6,5H12. So it does not make sense. Look at this. If you add this to this, it does not make sense. So let's see. C2H4, that is C3H6. And if you have C, then this guy, oh wow, I love the way this question was said. They want to test your idea. This is the answer. This guy and this guy are the same homologous series. Now because C2H6 is ethane, right? And C4H10 is what? Butane. So that is the way we move. So though there is a member before it, but they are still within the same range of what? Homologous. They are in the same family. Others there you see there, they are not in the same family. You can check them very well. So D is correct. Next one. Now, a consequence of global warming, popular question. Flooding, no time. Next one. Flooding is consequence of global warming. As you know, after global warming, what you start is that which of the following gases has the lowest rate of diffusion? Analytic theory of gas, Graham laws of diffusion. This is also very popular, but you guys have done it. Just focus on rate is inversely proportional to square root of density. So if we focus on that, we can just do that. The rate of diffusion is inversely proportional to. So that means the guy that has the highest molecular mass, we have the lowest rate. So all you just need to focus is on each of them. N2 is this guy. Nitrogen is N2. N is 14. 14 twos are 28. So what we are saying is our rate is inversely to 1 over square root of 28. You know what this means? If you don't know it, you need to understand. So we are looking for values. Just say this, if the rate is this one, square root of 28, the other one will be N2. Ammonia, not N2, NH3. Apologies. This is 14 plus 3 is 17. So the next one is square root of 17. And just like it should be equals to. And we are looking for the next one. Oxygen is O2. Hope I'm not cutting at me. O2 is 16 twos are 32. So the next one is square root of 32. The last one is maintain CH4. That's 16. 12 plus 4 is 16. The next one is square root of what? 16. So what we want to see now, remember this is inverse relationship. So what we are trying to do, dear students, is to make sure we know that the one that we has highest rate will be the one that has the lowest value of our lowest value here. And we take the square root. So we don't even need to do this. I'm just trying to show you. So for example, square root of 28 will be bigger than square root of 17. You know that. Square root of 32 will be bigger than. So the one that has the lowest value here, we have the highest rate. So the answer to this one is this guy 16. This is the guy at the 16. So let's move on. 29. 29 says the gas that is less dense than air is that. So if you focus on gases that are less dense than air, now we look at the component of air. Air is a mixture of gas, but from calculation, the logic I always tell students is just focus on this molar mass. If you consider the molar mass to be approximately 28 for air, so you just start focusing on the one that is a little bit less dense. So let's see the option CO2. CO2, carbon 4 oxide, is not. We just did this. I think it was 44. 12 plus 32, 44. You can see. Nitrogen is 14 times 2, 28. So that means that's what we're going to break. Chlorine is Cl2. 35.5 times 2 is 71. Oxygen is O2. 16 times 2 is 32. So the correct answer here, though it is subject to scrutiny, nitrogen cannot be said it is less dense than air, but we take it because nitrogen itself contains 78% in the atmosphere, and air is a mixture, it is present in the atmosphere. So we go with nitrogen because it's the one that is. So approximately this one, sometimes they can say 28.7, depends on the value. So nitrogen is the only one that falls within that range. That is the logic. Noted. Question 30. Now, question 30 says, which of the following equimolar solution has the highest conductivity? Conductivity of a substance depends on the number of what? The rate of dissociation. Let me put it like that. So if you check all this one, this is a weak acid, this is a strong acid, this is basicity of this one is 2. So this one is 2H plus, SO4 2 minus. NaOH basicity is 1. This is also the weak base. So the answer is what? H2SO4. 31, please. What takes place at the cathode during electrolysis? Yeah, the short what we do teach students in classes. We say PAHO NCR. Positive anode oxidation, negative cathode reduction. Cathode reduction. So, and there's another one we say oil rig. These are mnemonics we use in classrooms. Oxidation is loss, reduction is gain. I hope you understand that. So now what happened at the cathode? Reduction. So there's reduction. Cations are discharged. Okay, I love this. Anions are, we can say negative cathode reduction. Negative. What is negative ions? Anions. What is positive ion? Cations. So all the cations are gone. So what happened? Reduction. Anions lose electron. Loss of electron is oxidation. Gain of electron is what? Is reduction. So let's be careful about answers. Negative cathode reduction. So negative cathode reduction. So note that oxidation is lost. So at the cathode reduction occur, we need to be careful. Anions are oxidized. No. Anions lose electrons. So if you say anions lose electron, does that make sense? Anions are oxidized. No. Let's take an example. We said negative cathode reduction. At the cathode, negative ions are reduced. So anions are reduced. Reduction is gain of electron. So if you say Cl minus minus E minus, this is loss of electron. This is oxidation takes place at the anode. So So we have reduction takes place at the cathode. So if you say this is oxidation, okay, I'm just trying to confirm answer, guys. You need to be careful. This is technical. It is not cations. Cations don't. Anions migrate to the anode. Cations migrate to the cathode. So look at the mistake I made. You can see. Thank God. I will ask you that, but thank God I was aware that cations migrate to the cathode for reduction. So cations migrate to the cathode for reduction. So it's good to be careful. Cations are discharged. So note that this is positive anode oxidation, negative cathode reduction. Cations migrate to the cathode, which is the negative pole for reduction. So cations are discharged is correct. So you can see that's why you need to know the subject well, not to make mistake. Next question. Next one, calculation. This says how many grams of sodium hydroxide would be needed to produce 100 grams of 0.2 moles per dm3. How many grams? So let's start with number of moles is concentration times volume. We know the concentration in moles per dm3. We know this one in centimeter. You can see I have to divide by 1000. So number of moles is 0.2 times 100 over 1000 is 0.1. So this should be 0.02. So number of mole is mass over molar mass. The mass is what you are looking for. The molar mass of what is 40. So times the number of moles from what you just calculated is 0.02. So that's it. So the answer should be this guy. You can always check for any mistake. 40 times 0.02 is what? 0.8. So next one. 33 please. The formation of bond between hydrogen and highly electron. That's hydrogen bond. Hydrogen form bond with oxygen, nitrogen. If I say F, O, N, C, whatever. So when hydrogen combine with this, it is called hydrogen bond. So let's see. Results in dash. I love this. Very good. Hydrogen and highly electronegative, that should be hydrogen bond. But here we are not seeing, I think there is an error. Admin can quickly check question for me. That's just, this should be hydrogen bond between hydrogen and highly electronegative atom. It is not electrovalent. It is not this. So it is not dipole. So that is the only thing that can make sense. If those are the option, you can quickly check because the bond is called hydrogen bond and none of these options is carrying hydrogen bond. So I want to see if there's an error from what they typed. I'm not quite sure about that because I think this should be a straightforward question. So I'll come back to it while it's searching. Now the next one is the molecule that has non-polar, the only one that is non-polar covalent bond. That's between the same number of what elements or whatever that they are sharing. So that's that. Next one, please paper. What's the option in that question? Just need it. The next one is which of the following elements in the table below will react more readily with chlorine? If you're talking about reaction with chlorine, I want to compare ionization energy. I hope you guys know what ionization energy is and you can differentiate it from electronegativity, tendency to lose the electron. So if you want to react with chlorine, we are looking for the one that has high ionization energy. So out of all this one, which one and which one has what? High electronegativity, high ionization energy. So we just focus on this guy and this guy, 106 and 200. As you can see, that is correct. Now I go to the next one. Please check question for me. Now the next one, the relative molecular mass of a gaseous hydrocarbon is 30. The vapor density is what? Remember, relative molecular mass is twice of vapor density. So vapor density will be half of 30, and that is 15. 37, we just have to be on the... Are you there, please?
Yes.
Just keep it calm. Now consider the following reaction equation. This is a reversible reaction. Those are the things you have sometimes if you do inspect questions before coming online. So this is an endothermic reaction. Which of the following statement about this reaction is correct? Number one, the reaction is exothermic is wrong. It is endothermic because it's absorbed heat. the actual container would feel warm. This is also warm. Now, 198 kJ of heat is given off. No. 198 kJ of heat is absorbed. Endothermic reaction absorb heat. I hope you understand this. The next one. So the next one is 38. Which of the following property does not give evidence of kinetic theory of matter? We did this another time. Something related to this. Kinetic theory of matter cannot be explained, by polymerization, because you don't have polymers. Evaporation, all these are things you guys know very well. We can move to the next one. Question, next page. The next question is 39. I'm almost there. Time is not on my side. Well, we have a compound that could be tried using comp H2SO4 and not by calcium oxide. H2SO4 is an acid, so that means you are looking for an acid too, because acid cannot react with acid. I talked about this the other time. So out of all this one, it is only this kind, acid anhydride. Acid anhydride can be tried with H2SO because it will not react with it. Every other option will react with H2SO4 and not by calcium chloride. If you try calcium chloride with acid anhydride, it's going to react with it to form salt and water. Do you get that? The next 40. Positive ion in a sea of electrons are found in, that's what we call cloud of electrons. Cloud of electrons are found in what? Metallic bond. So it's just surprised the other question was parity bond. I will still check. 41. Dilute HNO3 does not produce hydrogen when it reacts with metal, because many times when we teach hydrogen and its compound, we tell you HNO3 is not used in the preparation of hydrogen, simply because it is what? A powerful oxidizing agent. It is a strong acid. I hope you understand. So next time you see that, just speak that. Next one, please. How many moles are there in 3 grams of O3? O3 is ozone, you guys know. So number of moles is what? Mass over molar mass, O3. Oxygen is 16. 16 times 3, I think it's 48. So that is 1 over 16 again. 0 point something repeating. 0.0. So 0.0, this is half. 10, then 0. This is also not there. So now you have 0.0625. That's 100. 16 times 6 are 96. So this is the right answer. D is correct. I hope you get that. Next one, 43. Yes, it's always like this. Sometimes we have to increase our pace so that we can actually get to the question and solve it. This one says copper 2 ions. Copper 2 ions are able to participate in coordinate covalent bonding. Anything that involves coordinate covalent bonding, you remember that only one electron, only one atom, only one element is participating in the reaction. Only one donor, coordinate covalent. Because they dash, the concept of bonding, of covalent bonding, is that there must be a vacant electron. So please note that. So it is not about copper being a transition metal or stuff. So please note that there must be what? It must have what? A vacant electron, that is unpaired electron. That is the reason why this can also. Other example apart from this is your ozonium ion and what? Ammonium ion. Next please, I'm there. 44. Determine the volume of 0.1 moles, 0.1 mole of hydrochloric acid in 0.25 dm cube of a solution. Numbers of mole is concentration times volume. I think we need volume. You can say volume from here is numbers of mole over concentration. Numbers of mole is 0.1. Concentration is 0.25. Just as 1 over 10 times 1000 over 250. Just doing year 1, year 8, I guess. And if I give you the answer, you use your calculator. So this is 2, 5, 5 over 4 over 5, which you know is 0. I think I've given the answer somewhere. Maybe conversion or something like that. Let's see again. Number of mole is Please, let's just use calculator. 0.1 divided by 0.25. So I think it should be 400, I guess. So it's 0.1 divided by 0.25, we can see. So let's do it in another way that is going to make sense. See, I think what I did is very correct. Yeah, volume is this, one is okay. Answer is in centimeter cube, you can see. So I still have to convert my answer by what? By dividing by 1000. So volume is 0.1 is 1 over 10. That sign is division. This is 250 over 1000. 0 into 2550. So I'm very right. This 1 over 10 times 1000 over 250. The only thing that can cause error is if 250 times 8 is not 1000, but I think it should be 250 times 4. Oh wow, that is where that one comes from. So 4 divided by 10, you can say 2 here 2, 2 here 5. Remember, I am to divide the answer by whatever answer I'm getting is in DMK. It is 5 in 20 is 4, 0.5 DMK, and that is what 400 CMK. I hope you get that. So don't let us waste time. The next one. Which of the following statements about gases is not correct? Kinetic theory of gas. I guess. The total kinetic energy E of a gas is not affected by collision. Yes. Gases, the total kinetic energy of a gas is not affected by collision. It's a very correct statement. From kinetic theory of gas, we are told that the motion of gas, are always in constant random motion. So second statement is also correct. Gases have low density compared to solid and what? And liquids of equal mass. Density of gases are low compared to solid. Yeah, I think you can do that from your density is equals to mass over volume. Density is inverse to mass over volume. So if you say something has high density, the volume, the space occupied by it will be small. So look at this now. Gases have low density compared to solid. Yeah, it's a correct statement because that means the volume of gases is large compared to solid, which we all know. Do you understand? So that's a good statement. It's correct. So if all three are correct, this guy will be wrong. Gases are highly soluble in water at high temperature. The thing about temperature is what the higher the temperature, the lower the solubility. You understand? Gases are highly soluble in water. I said the higher the temperature, the higher the rate of solubility. But for gases, please note that it is not like that. The higher the temperature, the higher the rate of solubility of solids and liquids. But for gases, the higher the temperature, the lower the rate of solubility. Question 45. I think I'm getting tired now, so I just need to finish up quickly. Arrange the following compound in their decreasing order of their boiling point. Now, the concept of boiling point is about their molecular geometry or stuff like that, or the intermolecular forces between them. If the bond joining those compounds is high, then you expect the boiling point to be high. For example, if you are talking about strong bond like hydrogen bond, you expect the boiling point of hydrogen bonded atom or compound to be higher than that of London dispersion force, or what you call Van der Waals force. So let's check it out. Now here, which hydrogen bond do we notice? Hydrogen and any highly electronegative metal. Hydrogen fluoride will be the strongest, no doubt, because it is what hydrogen and fluorine. Fluorine is the most electronegative element. Next is sodium. I said sodium. Ammonia. Ammonia is also going to form a bond. That is what also strong. Hydrogen and nitrogen is also what hydrogen bond. But fluorine is stronger than any other one. I just talked about that just now. So it will be like this. These are the two strongest, and they will be the one that have the highest boiling point. So you have two other ones. What are the two other ones? You have silicon hydride, that is silane, the way we call it, silicon hydride, and you have this guy, CH4. CH4 is methane. Two of them are covalent in nature. Let me say, two of them are having weak force, which is an example of covalent force. So, but silicon hydride, we have higher boiling point than this guy, simply because the size of this guy is bigger than the size of this one. So another teacher will tell you the higher the size, the higher the boiling point. Fine. In the case of two compounds that are having the kind or the same intermolecular bond, you look at their size. So the order will be, in decreasing order will be hydrogen fluoride will take the lead, followed by ammonia, followed by silane, which is silicon hydride, and followed by what? The methane. So correct answer is choice C. We can go to 47, 48, 49, and 50. 47 now. Thank you. The following statement are correct except dash. Let's start. Energy is released when liquid change to vapor. Energy is released. Yes, energy is released when you're coming back from what? Remember entropy. When you are coming from what? Gases back to what? Solid. So liquid back to solid is what? Energy is released. Energy is released. Well, that is an exothermic reaction. That is a correct statement. We are looking for except. Particle move faster in gaseous than solid. No doubt about that. Kinetic theory of gas. These are correct statements. Carbon atom in gaseous methane are further apart than the one in solid. And let's take this one. Methane is tetrahedra and diamond is carbon. You know that diamond is carbon. So let me just write it is octahedra. So talking about space, we are talking about, okay, the diamond octahedra, they form ball. Bulk mixed for learning, the way they call it, you know, the A-level class, you don't need that. So you expect it to be closer, true, because they are tight, they are from octahedra. So this is correct. The only one that is going to be our answer should be this. There is a large decrease in volume of solid metal when pressure is applied. The truth about this is what? Talking about the volume, we say solid substances are what? Incompressible, like they cannot be compressed. You understand? Most solid cannot be compressed. So you cannot actually predict the volume of a solid substance when pressure is applied to them. Please note that. Next is question 48. The vapor density of an organic compound with the same concept. The same concept. But the same word with the molecular formula C2H4O2. C2H4O2. So let's get the molar mass, relative molecular mass. You can be 12 times 2, 2 and the 4. 1 times, hydrogen is 1 times 4, 4. Then 16 times 2, 32. 36 plus 24, 60. We said the vapor density is half of what? Relative molecular mass. So 30 is half of 60. Next one, 49. A mixture containing two salts of different solubility. The factor that defines what the separation of salt of what different solubility is called crystallization. So no doubt this one is talking about migration. This one is talking about boiling point. This guy is talking about what? Solubility, and the last one is talking about two substances. One must be solid and the other must be liquid. Admin can show the last question I'm solving. Number 50. The separation techniques that is suitable for separating iodine and tetrachloromethane should be dash. Iodine. Now, normally you should think of iodine crystal to sublime. But if you watch the sublimation is not there. So next thing you think about is that can iodine dissolve in tetrachloromethane? What is the solvent for iodine? Benzene, right? Or methane or benzene. So iodine crystal cannot dissolve in tetrachloromethane. So because of that, you're talking about solubility again. So be careful to know that what is going to be this guy, solvent extraction. It cannot be filtration. It cannot be decantation. Now you can think about fractional distillation, but you are talking about difference in boiling point. So please note that correct answer is solvent extraction. That is the way you can actually do this. That is the use of Solubility condenser. So that's just that about this. There are some questions. I don't have the something here. There's one question or two I was missed. I don't know, but it's just a pity. I'm going to stop. I'm going to stop this video. So guys, if you have anything, comment, any error you found, then let me know. I will attend to you guys. Thank you very much, and I will see you soon. Bye for now.